We are now recording. Okay, so starting from the top of page 3, you guys find where there are horizontal tangents to the curve of that funky polynomial there without using your calculator. Now, yes, can I use the calculator and find horizontal tangents? Absolutely, I can. But I won't do that right now. I'll show you how you can actually verify this in the calculator in just a little bit. But let's just do this. Let's do y prime equals 4x cubed plus 4/3 times 3x squared minus 12 times 2x plus 0. Remember, the constants are 0. And you want a horizontal tangent, so it means you want y prime to equal 0. So remember, horizontal tangent, the slope is 0. We know this. So 0 equals 4x cubed, clean that up, plus 4x squared minus 24x. Okay, again, we're using the shortcut rules now. If you did the limit definition of this, you would go crazy. You don't want to do that. Factor out 4x, you got x squared. So you got to be cool with your factoring, right? That's why we did have that summer assignment. And continue breaking it down. For math teachers who, there was a movement a few years ago, like, oh, factoring is not necessary. Yes, you can get by math without having no factoring, and there's ways to work around it. I would beg to differ. I'm more old school with my math, and it's a skill that you really want to have to be able to pull out of your back pocket. So if you have a little trouble factoring, talk to me. I'll help you. But I think it's pretty important. Anyway, that's x plus 3x minus 2. There are ways you can do that, but that's a pretty easy one. Just two numbers that multiply -6 and add to 1. If you FOIL it, you would get back to that. So anyway, what values of x would make this true? Obviously 0, because I would make that 0 right there. -3 and 2. So that's where I have horizontal tangents at those 3 locations. So questions about that one? Let's actually verify this. We'll go to Desmos. We have a question in the chat. Oh, we said equal to 0 because we want a horizontal tangent. So remember, we took the derivative, and we have a horizontal tangent. Derivative will equal 0. That's a connection you have to make. Why? Because remember, the tangent slope of the tangent line is the derivative. And if you have a funky curve, if I drew a tangent line at sorry, if any of my tangent lines I draw to the curve is horizontal, I know the slope is 0. So that's why I set the derivative equal to 0. Okay, so x4, 4/3 x cubed. Hold on a sec. So y equals x raised to the 4 power plus 4/3 x cubed minus 12x squared plus 7. Okay, let me clear my screen first. I'll undo it. But we kind of see that if I were to trace, it seems like I do hit a low point at -3, hit a high point at 0,7, and hit another low point at 2, -14.33. So it seems like as though that's where I'd have horizontal tangents. That's one way you can do it. Another way you can do it too, to verify, if you go to your TI-84 calculator, okay, it's taking a sweet little time. I will probably need to get a description to this, but sorry, I'll do that later. I cleared it from before. That's okay. X to the 4 power plus parentheses 4/3 x cubed minus 12x squared plus 7. Remember, I do alpha window and deriv, x alpha trace y1, x equals x. And I don't care to see the first one. I'm going to turn it off. I really want to see the derivative. And we'll graph in the standard window. Now, this is the derivative graph, mind you. Notice I see an x-intercept here, an x-intercept here, and an x-intercept here. Again, this is the derivative graph. The derivative equals 0 at those 3 places. And that's what we found analytically when we took the derivative set equal to 0 and solved for x. So that's the way you can verify your work too. Is that. That's why I said no calculator. So on the AP exam, this is totally a multiple choice question without a calculator. I would bet serious when I do it asks us at least once if they do multiple choice this coming spring. They've done this every year for the last 60 years, a question like this, so without fail. So that's one type of question that I'll probably ask too on our test. Okay, now we're going to move on to something brand new called the product rule. Then we're going to talk about the quotient rule. And then we're going to talk about the power rule again and kind of combining some things. I kind of already did this part, just so you know. So in some ways, I actually already did the last page of the notes, how to check your answer, like put the function in and then check it. So we'll revisit that. So anyway, product rule. So it looks a little confusing, but the bottom line is this. If you have 2 things being multiplied, what you do is you keep the first thing intact, you multiply the derivative of the second thing, plus the derivative of the first thing times the second thing kept intact. The order in which you do it doesn't matter because you're adding. So you have 2 functions, f of x and, sorry, I just have one function, f of x, but I have 2 different things being multiplied here. I'll call this u, and I'll call this v. Now, I haven't taught you derivatives of trig functions yet, but here I'm telling you that's secant squared x. So that's going to be the derivative of tangent x. We are going to do derivatives of trig functions in our next unit in November. Crazy that we're almost getting to November. Anyway, so my derivative is going to be u times v prime plus u prime times v. Sorry if my u's and v's kind of blend in. I'll do my best to make my v's a little more sharp and my u's more rounded. Or to make my u's differentiable, my v is not differentiable, right? At the corners. So u straight up is 4x squared plus 6. And the derivative of tangent, you're told, is secant squared x. Great. Plus the derivative of u, which is going to be 4 times 2x plus 0. Because derivative of 4x squared, remember, you take the x squared bit, move the 2 to the front, drop the exponent by 1. Derivative of 6 is 0 as a constant, and then leave the v part intact, which is tan x. Clean it up just a tad. 4x squared plus 6 times secant squared x plus, that's going to be 8x times tan x. And there you go. No need to distribute. Just leave it like that. You're good. That is a product rule. It can be very efficient when you start dealing with like some really nasty terms being multiplied together. Sometimes you have no choice but to do the product rule. So as long as each part of your function, the 4x squared plus 6, the tangent x, as long as you can find derivatives of those, you're okay. You'll have a chance to practice that in homework, and then we could talk about that. But It's very, very straightforward. Don't overcomplicate it. Quotient rule is another one. The way the quotient rule works, it looks a little confusing, but I like to think of it like this. If you have two things being divided, it's like saying u prime times v minus u times v prime over v squared. There's actually kind of like a little nursery rhyme that some calculus teachers use. This is called the high function. This is called the low function. And so if we think about it, it's high, sorry, it's the low times d high minus the high times d low over low squared. And so here's how the nursery rhyme works. Low d high minus high d low over low squared, and away we go. If you like that. So again, low d high minus high d low over low squared, and away we go. If that helps you to memorize it. Of course, you have your notes, but on the AP exam, you do need to know this without dative notes. Again, you'll be practicing so many times, so you'll have it down cold. The way I used to remember when I was in high school, I just remember you have to take the derivative of the first thing you see. So you always do that first times v, and then you switch it around. I don't know if that helps, but so low d high minus high d low over low squared, and away we go. So let's actually apply this to this function here. So you have x cubed over x squared plus 2, and then you're also asked to find the equation of tangent line of that. Again, if you did the limit definition of derivative, you would drive yourself nuts. Let's do our shortcut rule. So f prime of x. So again, low, which is x squared plus 2, times d high, so deriv x cubed, minus high, times d low, so the deriv x squared plus 2, over low squared, and away we go. And notice what I do is I put the expression that I'm going to take the derivative of, I put it in parentheses, and I put a little accent mark just to show I'm taking the derivative. Then I actually do it. So x squared plus 2 times 3x squared minus x cubed times 2x. Remember, the derivative of 2 is 0, so you ignore that. That's a constant, but x squared is just 2x. And don't bother foiling the bottom. It's not necessary. I don't really care. And to be honest with you, you're done. I don't care if you go any further. In fact, I encourage you not. This is kind of counter to what your math teachers in the past have told you. The reason I encourage you not to go any further is that on the AP exam, on the free response, if you're to go further and make a careless mistake with your algebra, you would get nothing. They would score this as a 0 if this was a 1-point problem. And probably would be a 1-point problem because they have 3 or 4 of the parts. And that would suck. I don't want that to happen to you guys. So honestly, I really don't care whether they simplify or not. I mean, you could if you want. I mean, I'll do it in case if this is really bugging you. That's gonna be 3x4 plus 6x squared. I think I'm doing this right. Minus 2x4. And by all means, do not FOIL that bottom. That's not necessary at all. It does this. It benefits you. Doesn't benefit you at all. It's actually a waste of time. But up top, we got x4 plus 6x squared. So it does look a little nicer, I guess. But again, I don't care whether you simplify or not. I actually prefer you don't. So there you have it. But anyway, now you have to find the equation of the tangent line. I suppose it is easier to plug a 1 into the blue than the red. So f prime of 1 is going to be 7 up top. And down below, you can see why I didn't waste my time foiling, because I didn't need to do that. That's 1 plus 2 squared, so it's 9. Any question how I got that? Again, we're finding the equation of the tangent at x equals 1, so I got to find the slope at x equals 1, which is the derivative at x equals 1. So any questions how I did that? No? Okay. And if I plug it into the red, I'd have 1 plus 2 is 3, times 3 is 9, minus 2. That's not that much work. So then your equation will be y, and then of course we do need f of 1, and I'll get to the question in the chat in just a sec. F1 is going to be 1 over 3. So it's y minus 1/3 equals 7/9 x minus 1. And please do not waste your time putting this in slope-intercept form. The College Board doesn't care. Leave it like that. Okay, question in the chat. Yeah, the tangent line part again. So for the tangent line, again, once you have your derivative figured out using the quotient rule, if you want to find the equation of the tangent line, remember, the equation of a line is this. Let me do this in green. The equation of a line is y minus y1 equals m times x minus x1. That's in point slope form. The m is that, which I had to use my derivative. And we had to do it at x equals 1. So I plug 1 to my derivative. That's a slope. And then x1, of course, is 1. And y1, just plug in 1 to the original function. The y value associated with x equals 1 is 1/3. So that's that one. And that's something I could probably put as a multiple choice question. I could say, you know, here, because you can't really work backwards, you actually have to work this out. Well, I lied. You actually could do the n deriv feature in your calculator. You could do n deriv and plug in 1, and it'll give you 7/9. But I still want to see your work. But or maybe I could just say which of the following is a derivative of this. But yeah, I like this question a lot too. Actually, to verify we did this correctly, let me show you really fast that we know that this makes sense. X4 plus 6x squared, x squared plus 2 squared. So to verify that really quickly, this is going to be the last page of the notes, because it is a little, it is a little much that we did. So let me go ahead and clear that. So x4 plus 6x squared. Actually, no, let me just keep that up first. So remember, that's I could go alpha y equals, I could do as a fraction. That's x cubed over x squared plus 2. Yeah, x squared plus 2 in parentheses. No, just x squared plus 2. Just do that. I'm going to turn that off. My drill will be graphed. But then I'm going to type in the expression that I actually found by hand, which was x4 plus 6x squared all over, excuse me, parentheses x squared plus 2 squared. These should be identical. So these two should overlap each other. So the first one's kind of slow. And you don't see anything new after that. Let me go and clear my screen so you can see this a little better. If I hit trace, you can see Y2 is selected, and if I hit down, now Y3 is selected, and they are totally overlapping each other. If I go up or down, they're the same curve. That's how you verify your work, that you've actually did the derivative correctly by hand. This is the original function. You told the calculator it's graphic derivative, And y3 is what you actually found by hand. Y2 and y3 should be identical if you did the derivative by hand correctly. And that is essentially the last page of the notes here. If you're given this function, which we had in example 11, and we found as a derivative, you plug in the original function, do the derivative bit, then plug this in. And actually, you can even change the style of that just to see it overlaps it. So if I go back again, if I want to kind of like change the style of that line, hit enter, so make it thicker. So there's the first one again. So you can see it's tracing it. So another thing you can do as well. So essentially, I kind of already did the last page of notes for you guys. So we should be able to wrap this up pretty soon. Let's take a look at number 14. Now 14, you could go about a few different ways, well, a couple different ways. You could do a quotient rule if you like. So y prime would be, so low, d high, which is 0, minus high times d low over low squared. And away we go. Well, that's going to be 0 minus 5x4 over x to the 10 power. If you were to simplify, again, I said I didn't care, but if you were, you'd have negative 5 times x to the negative 6 power. Or we could have done this as an alternative. Rewrite this as a negative exponent. That's why we had this on the summer assignment. I want to make sure you guys are very comfortable in rewriting exponents. And just do your power rule. Personally, I like this more than what I did in green. You could do the quotient rule. It always works. Just sometimes it's not terribly efficient, especially if you make a mistake up here, so many moving parts. If you could write a single term with a negative exponent, by all means do that. And that's just basically an extension of the power rule down here. The power rule, x to the n power, can be applied whether n is positive or negative, doesn't matter. So if I have x to the n power, again, just do this. And who cares if n's negative? It doesn't matter. Same thing. That's all. And I have different notations. F prime, d dx of x to the n doesn't really matter. By the way, n could actually be irrational or rational. It doesn't matter. We'll talk more about that later. But as long as your exponent is a real number, you can do this power rule. It's totally fine. Like if I have like x to the negative 4.8 power, if that's y, then what's my derivative? It's just going to be negative 4.8 times x to the negative 5.8 power. That's all. That's all you're doing. Just move the exponent down to the front and drop the new, and your new exponent will be dropped by 1. That's all. Let's try this a few more times, and then we'll wrap it up. So actually, we'll probably go to about 9:55, so about 15 minutes for homework review at the end. So I was hoping for more time, but that's okay. But if you're cool with the homework, if you're cool with worksheets 10 and 12, feel free to get a head start on the new homework, which is already posted to Schoology. Y prime is going to be 2 times 7x6. Oh, by the way, let me backtrack a little bit. Let me rewrite that as y equals 2x7 minus 3 times x to the negative 6 power. Now, let me take my derivative. 2 times 7x6 minus 3 times negative 6x raised to negative 7 power. Remember, x to negative 6, you move the negative 6 to the front, drop the exponent by 1. And of course, leave the negative 3 intact because it's being multiplied with. So your derivative is going to be 14x6. And you have a net minus 3 times negative 6 plus 18, x negative 7. And you can leave it like that, or you can put it over x7. I don't really care. That's the derivative of y there. Again, we're just doing things that are very, very mechanical. Any questions? Nope, okay. Let me clear again. Problem 16 here. This one's kind of interesting. This is actually very popular in the AP. You just have to just apply the derivative. So obviously, you take a derivative of all these things here. So that's going to be 7u prime minus 3w prime minus 5. And then you have uw being multiplied together. So we need to take the product rule of that. So that's 7u prime minus 3w prime. Remember, you're doing a derivative, so that's why I'm using the little prime symbols there. And you have to do the product rule, which is going to be u w prime plus u prime w. Honestly, I don't care which one you do first because there's a plus in the middle. You could do u prime first, then w, and then uw prime. I don't care. And you already know what these values are. So u prime is -1, so I'll do 7 times -1. W prime is 3, so do 3 times 3 minus 5, and then u itself, when you're plugging in 5, because you're doing this at x equals 5, u itself is 10. W prime, of course, is 3. U prime is -1, and w itself is -2. Before I go any further, take a moment, take a deep breath. Do you guys see what I did? If you have questions, or I'm going to explain it again. All I'm doing is taking the derivative of each of those expressions. U is some function as x. I don't know what u is exactly. You're told that u is some function in terms of x. Likewise with w. And you're able to take the derivative, so it's differentiable, able to differentiate, to take a derivative. And this is an operator. It just means, hey, I'm just taking a derivative of each of these things here. And 7 is a constant being multiplied to u, so that's 7u prime. -3 is a constant being multiplied to w, -3w prime. And -5uw, remember, u and w are being multiplied, so we got to use the product rule. So it's the derivative of uw is uw prime plus u prime w. Or you could say u prime w plus uw prime. I don't care what order you go in, because there's a plus in the middle. The quotient rule, you do have to follow the right order, because there's a minus in the middle for a quotient rule. And then you just plug in stuff you know. Like, okay, derivative of u was -1. Derivative of w was 3. And then u itself is 10 and w itself is -2, and just throw it in. And then you just got to clean it up. -7 minus 9. And you will have practice on this in the homework, just so you know. And we'll do this in class on Thursday. 30 plus 2, because remember, you have the double negatives. So it's -16 minus 5 times 32. -16 minus 160, so you get -176. Now the College Board loves this because you can't really use like strategy, like working backwards, or you can't use a calculator. Like you really got to know the concept. That's why this is a very popular question on the AP exam. It really is check and make sure you know the concept of constant multiple rule as well as the product rule. And then for B, we're doing the quotient rule. So that's just going to be W prime. Remember, it's just low D high. So U times W prime minus high D low over low squared. And away we go. So U is 10. W prime is 3. W is -2. U prime is -1 over U squared, which is 10 squared. So 30 minus 2 over 100. 20 over 100. And you don't have to reduce it, you can leave it like that. Okay. Any questions? Okay. So again, you guys will get a chance to practice this in the homework. In fact, if I pull up the homework really quickly, homework images, homework number 14. Yeah, I see it right there, number 23. So number 23 is very similar to what we just did, and the answers are right next to it in blue. So you definitely have that opportunity to practice that. If you like to do more practice, you can do the evens. I'm only assigning the odds, just so you know. But yeah, you totally can practice that. Okay, given the time, I still want to keep going with this. Worksheets 10 and 12, I will actually do that with you guys on Thursday. I'll review that. So if you still want to, if you didn't turn it in, you want to wait a little while, that's fine. I am going to do the solution for worksheets 10 and 12. I didn't get a chance to do that this weekend. So worksheets 10 and 12, I still need to do those solutions. I do need to work out the test from last year, work out that answer key. I'll probably text Mrs. Blanford to see if she can, plus I'll wish her luck for her Dodgers because she's a huge Dodgers fan. But I'll see if she has that, so maybe I don't have to do that, but I will if I need to. And then the board problems, I need to work that out also. So anyway, one last thing, and then once we finish this page, then we'll do we'll see if anyone can beat my score of 94%. If anyone's brave enough to share their screen and do this in front of the whole class. But anyway, let's do this right here. So what's the derivative of this bad boy? Well, that's easy. It's 2 times 4x cubed minus 5 times 3x squared. Remember, doing derivative of x4, which is 4x cubed, derivative of x cubed is 3x squared. Then just doing the power rule, plus 11 times 2x. Derivative of 5x is 5 itself, because derivative of x, remember, the derivative of x is x to the 1 power. That's 1 times x to the 0 power. Anything to the 0 power is 1. And x just has a slope of 1. So we just say -5, and then plus 0. So clean it up, I get 8x cubed minus 15x squared. I am cleaning it up because you'll see why in just a second. The question is, can I take the derivative of this function? So can I do the derivative again? Of course you can. If you do it, it's called the second derivative. So absolutely, you can do the derivative as many times as you like. But ultimately, you're going to get to a point where you just have a 0 as your final answer because you've done the derivative every single term but many times. Assuming that you're doing power terms or a polynomial or something like that. But sure, absolutely. The second derivative here is going to be easy. It's going to be 8 times, let me do it in blue for a bit of contrast. It'll be 8 times 3x squared minus 15 times 2x plus 22 minus 0. Clean it up. It's going to be 24x squared minus 30x plus 22. Can I do it a third time? Sure. Why not? Let's do it again. That's going to be 48x minus 30. Can I do it a fourth time, the fifth time, the sixth time, seventh time? Absolutely. You can do it as many times as you like. Just so you know, we rarely go past the second derivative. Graphically, there is a significance to knowing the second derivative, which we're not ready to have that discussion yet, but we will have that probably sometime in November or December. It actually plays a key role in how the curvature of your graph looks, but we'll have that discussion later. We rarely ever do third derivative. Third derivative kind of has some application, but we don't really talk about it. Just to know, notation-wise, if you want to use this notation for second derivatives, you actually write the second derivative like this. It's kind of weird. I'm not sure who came up with this, but you write like that, or you write like this. You can write d2y over dx squared, or you can write d dx, which means the derivative of the derivative. So this right here, just so you know, means the derivative of the derivative, because that's what you're doing, right? So anyway, that's what's happening there. That's just a notation thing. Okay, so there's a lot we covered, but again, it's not very abstract. This is very, very concrete stuff. Maybe example problem 16 was a bit abstract, but I think for the most part, this should be pretty concrete stuff. It's just formulaic, and you just practice. If you're stuck, try, obviously try the problems. See you during office hours tomorrow or Thursday. But yeah, it's very, very mechanical, and we'll have a chance to do more of this. So Thursday, I'm not doing any new material. We're just going to review for the test. So we'll do the board problems. I could see if any questions, people have questions about like the exam from last year, if you have that stuff. I'll see if I could dig up some other review problem sets. But the textbook, I suggest problems in the study guide. That's another great place. Yeah, so I'll see if I can find other stuff. But I think for most of you guys have the materials you need for review for our test next week. And of course, we're doing all review on Thursday. Oh, and I am going to hold the special office hours next Monday. Trying to figure out what time I did last time. I think last time I did it at 2 o'clock. I might do it a little earlier because we don't really have community life. I don't know. What do I have going on next week? Actually, I will have to do it a little later. So yeah, so we'll have to do it up. So I'll probably aim to do another 2 o'clock special office hours next Monday. It's optional. You don't have to make it if you don't want to. But I will be available for 1 hour from 2 to 3 next Monday. I'll send an invite for that, and make sure you guys you do that. Okay, so let's go back to that link again, and let me stop the recording.